Hi, let's walk through how to create a linear regression model for the cricket chirps and temperature data. Before we create a linear model, we first have to determine if the data has a linear relationship. We can see this by plotting the data points and checking to see if there appears to be a line in the data. We also have to look for the correlation coefficient. The first step is to read the data set into our program that we want to use for our model. The data we have is written in a CSV file. In order to write this data into our program, we're going to use a data analytics library called Pandas. To import it, we write the following. To read our CSV data and store it in a variable, we need to call the readCSV method. Now, the variable data is storing the entire data set. We can then extract the x and y values from the data set by using the following code. Now we need to plot the data. We will use a library called matplotlib to create our visualizations. So let's import it. Let's visualize this data as a scatter plot. To create a scatter plot, we first have to make sure that it is the right size so that it fits in the output window on the right. We can set the size by doing the following. This sets the width and height of the graph in inches to 5 inches by 4 inches. Next, we create a scatter plot with the x and y values we extracted from the data earlier. We call the scatter method and pass x and y as arguments. To make this more user-friendly, let's add labels to the x and y axis and also a title. To show the graph, we need to call the show method. When I run the program, you will see the graph as our output. The second thing we needed to check in order to determine if there is a linear relationship was the correlation coefficient. To compute the correlation coefficient between the chirps and temperature columns, we write the following code. This will find the correlation between x and y, the temperature and chirps. In the console, we see that we have a correlation coefficient of 0.98. As a reminder, the correlation coefficient is between the values 0 and 1. The closer the value is to 1, the stronger the linear relationship. So this data has a strong linear relationship. Now that we've determined that the data has a linear relationship, let's create a linear regression model. We need to use another library called sklearn, so let's import it. sklearn needs the data to be shaped in a very specific way. We need to turn the x value into a 2D array. Once we have the data formatted, we can create a linear model by calling the function fit from the linear regression module. This creates a linear equation based on the input values. We can now obtain useful information we need from the model, including the coefficient, intercept, or bias, and the r-squared values. To find the coefficient, we write model.coef_. To find the intercept or bias, we write model.intercept_. To find the r-squared value, we have to call the score method and pass it x and y. You may also notice that the values for the coefficient and intercept are treated as floats. We're also rounding the values to 2 decimal places. Let's print these values to see what the output is. We can also input values into the model and ask it to make predictions. So if we wanted to predict the y value when x is 77, we can do the following. Let's print this prediction to see what it predicts. Here you can see that the predicted y value when x is 77 is 42.04. Okay. Using the values we calculated, we can now add the line of best fit to our visualization. A line follows the equation y equals mx plus b. where m is the coefficient, x is our x data, and b is the intercept. In our code, we need to plot this line, and we can customize the color and add a label by doing the following. Let's rerun the code. To make it clear to users what this red line represents, let's also show the legend. Great! Now it's your turn to explore these examples.